Welcome to the Working Without Waste podcast, powered by ERC Midwest, the podcast that's all about sharing ideas and stories that increase your productivity and decrease waste in your business and personal life. I'm your host, Mike Malatesta, one of the leaders here at ERC Midwest. Our guest today is Zach Marlin. Zach is our Transportation and Treatment Group Director here at ERC Midwest and the author of our newest ebook titled The Life Cycle of Wastewater. Today we're going to talk about wastewater treatment. Specifically, Zach will walk you through how we manage our clients' wastewater, a process that his book covers in great detail. If you'd like to get a copy of the Life Cycle of Wastewater ebook, you can find it on our website at www.ercmidwest.com. So Zach, welcome to the show.
Thank you. Thank you for having me.
Yes, this is very exciting for us because this is our first creation of an ebook, and your first published author work as well. So it's an exciting day for us, and I'm happy to share this with everyone that's listening. So before we get started, Zach, why don't you give people a flair for who you are, where you came from, and how you came to write this book in the first place?
Yeah. I guess I grew up in Milwaukee, Wisconsin. I primarily lived here my whole life. I did have a brief stint out east. I lived in Vermont for a while. When I was younger, about 20 years old, did a lot of skiing out there in the winter. It was a great time of my life. And actually, after I came back from Vermont, I ended up working for a very small wastewater treatment company. They primarily focused in ultrafiltration, and that's how I got into the wastewater world. From there, it just kind of snowballed effect. I met a gentleman named Kevin Crosby, who started a company called Elite Environmental. At that point, it was just Kevin, and I started getting introduced into different types of treatment. So I was familiar with ultrafiltration from my previous original employment at this smaller company, but then I met Kevin and learned about chemical batch treatment and metals precipitation, acid breaking or oil emulsion breaking, and that was like the footprint of my career and the start of it, and it's just kind of taken a snowball effect, as I said, from there.
Okay, super. So you basically started in this industry as someone who probably had no awareness of it prior to starting. Would that be fair to say? Yeah,
that is correct. So it kind of fascinated me. So when I first got in the industry, I just saw so much potential, and it was like a twofold thing. So it was the industry, and then also being a part of a smaller business really intrigued me too, because every action that I took had a direct result that I could see. So some of my previous jobs, I worked for fairly large corporations, and at that point in my life, I didn't see that my actions had a direct effect. But starting out in the wastewater industry, and then also starting out in a smaller business setting, really kind of started driving that motivation and that developing the drive to really achieve as much as I could in this industry, based on direct results that I saw from my actions.
Yeah, and it's an interesting world we live in, because what we do with wastewater most flies under the radar of most people. So even people that are in the industries that we service, most people understand that when they put the water on, it goes down the drain in their house, or they flush the toilet, the water goes down the drain. And they don't really have an awareness of where it goes. And even though that's not what we focus on, ultimately our water that we treat and recycle goes to the same place as the water from homes and such. But the fact that industry and all types of activity generate or contaminate wastewater that needs an intermediary step to come to a facility like ours, for example, to have pollutants removed from it is something that not many people know about. And we want to, your book demystifies that, and I want, we want people to know more about what happens to that, because it's a very important part of the manufacturing process. It's a integral part of the work that's needed to make all of the things that we enjoy and take for granted in life, your clothes and your home and your car and everything, but also the impact that it has on the environment. I mean, we're serving a very valuable role in water's sustainability cycle, which is why I think it was cool the way you titled the book "The Life Cycle of Wastewater," because wastewater does have an infinite life cycle, theoretically at least. It's one of the few things that can be continually cleaned and reused over and over and over again. There's not many things that can do that. So this industry, this sort of fly below the radar industry, let's start at the beginning. Some process contaminates wastewater, whether it's at a factory or wherever, and they can't discharge it into the sewer. What does somebody do, and how do we help them with that? And how does your book sort of take them through what the steps are?
Yeah, so I think the first step would be to identify what type of wastewater you have, and reaching out to a company like ours, ERC Midwest, would help. We would be able to help guide you on that based on our analysis. But the first step would really be identifying what is creating the type of waste, and that starts with the waste profile or the waste characterization profile, which is going to kind of break down all the different qualities that waste might have. So physical characteristics, the process generating the waste, and then ultimately, how that waste, what potential contaminants might be in that waste. And that's really the first start of everything is the profiling process. And that allows us to identify what types of treatment methods would be effective, coupled with a sample of the material. The sample is very important as well, because that's going to allow us to determine its treatability, the best disposal method, and then what ultimately the best treatment method too would be applied to that material.
So when you get a sample of wastewater, Zach, what do we look at? What do you look at to make the assessment that you were just talking about?
Yeah, so the first thing that we would look at is physical characteristics, and to ensure that, for example, the pH of the material is within an acceptable range for non-hazardous wastewater treatment. So that'd be between a 2 and a 12.5. We're looking for flash point. What is the flash point of the material? Once again, for non-hazardous wastewater treatment, we want to make sure that flash point is greater than 140 degrees Fahrenheit. Another very big, important part of the makeup of the waste is also the heavy metal content of the water. So what type of heavy metals could be present? And then there's a whole slew of different types of other contaminants as well that we want to look at. So volatile organic compounds, semi-volatile organic compounds. And part of that too is actually just the process that's generating the waste, because some processes generate waste that might have to go out for hazardous waste disposal. So all those things tie in together to really kind of encompass how to best manage a certain client's waste stream.
Okay. And so when you can't just look at a wastewater and tell what's wrong with it, in other words.
Yeah, that's true. Yep. So basically all of those key components for analysis are done in a laboratory, our laboratories. And we have different types of instruments that are used for each individual contaminant to be able to identify that. So for our flash tester, we use a closed cup flash test method, right? So essentially we'd add X amount of liquid into our flash tester and slowly ramp up the temperature from 60 degrees up in 10-degree intervals, while applying flame in a physical flame within those 10-degree intervals to see if there's actually ignition of the material. That's how we would check for flash. If you're going to check for heavy metals, we have a special instrument called an ICP mass spectrometer, or excuse me, an ICP unit that is used for analyzing heavy metals through aqueous injection of a sample into this instrument that is then atomized into basically a plasma. And then as that material is entered into the plasma, to break it down pretty simply, based on the wavelength that is given off when that material enters the plasma, we can tell what type of heavy metal is present in the wastewater. Another very common tool we use is just the pH meter. So just seeing how acidic or how alkaline a wastewater is also a very crucial part to understanding the overall composition of the waste. That also affects treatment, because if we have a wastewater that's fairly acidic and potentially buffered, where there's other components in the waste that prevents adjustment of the pH, which is part of the treatment process, also determines the treatability of the material. So there's a lot of different factors that go into the analysis of a wastewater stream.
Okay, so we use a lot of sophisticated laboratory equipment to help us make the determination of what we're up against when we receive a sample. That's how we decide whether we can treat and recycle the wastewater.
Yep, that is correct.
Okay. All right, cool. So so that the waste profile, the sample, everything's good with both of those. I assume that's like an okay. Okay, we can manage this. There's some type of process that we go through to alert our team and the client about that, and then I guess we send a truck to go pick up the wastewater and bring it back to one of our plants. And so when the truck arrives, what do we do then?
Yeah, so when we're actually at the client site and we're physically removing the material from the holding vessel that the material's in, which could be a wide array of different types of holding vessels, whether if it's a tank or a tote. But the first thing that's going to happen is we're going to identify where the material is, and then also we're going to do a real quick pH test on that material prior to picking it up, based on the knowledge that it's a non-hazardous waste stream. Now, we also do transportation and management of hazardous waste streams, but that's not coming into the plants for our treatment process. We're specifically treating non-hazardous wastewaters. So one key thing is our drivers are always checking the pH, because depending on the alkalinity or acidity of the wastewater, if it dips below a certain pH or above a certain pH, we would have to look at an alternative method at that point in time to handle the material, whether if it's pH adjusting on site or looking at management of the material as a hazardous waste. But once we determine that the material is okay to pump via that pH strip and knowledge of the profile of the sample, a vacuum truck would be used to physically pump the material out of the truck. And essentially it's just that, it's a large vacuum, right? So it's removing air from inside this big tanker truck, creating a vacuum, exhausting the air out while pulling the liquid in. So that material would then be loaded and secured in the truck. We lock all the caps on the trucks, ensure that our load is secured. There's then a manifest that's completed that is associated with that specific waste stream. So it covers shipping purposes for the DOT and RCRA, but then also that manifest holds a very key piece of information on there, which is a profile number, which I guess I didn't elaborate on earlier, but once we accept a waste stream, it is issued a profile number. That profile number is a unique fingerprint that's going to stay attached to that specific waste stream. And that profile number moves from all different types of documents. So we clearly communicate throughout the organization, whether if it's a truck driver going to pick up the material, or a plant operator is offloading the material, or a lab technician who is analyzing the material. Everything about that specific waste stream really derives from that unique profile number that's assigned. So that is also on that shipping document that driver would have when we're on site removing the material.
Okay.
After the material is pumped, we would then have the manifest signed by the generator. The truck driver would also sign the manifest. The load would be secured, and then he'd be off on his way to the water treatment plant.
Okay. And once we get there, so we've had the initial sort of evaluation of the waste by sample and by analysis, then we have our driver plays a role in making sure that at least one potential hazard, which is the pH, is okay before we pick it up. And then we drive it safely to one of our plants. And what happens?
Yeah, so it's very important what happens. So the material is then sampled again. So the first thing that happens is the truck would back into the plant. We would secure the truck by chalking the wheels. We also have to sample the truck accurately. So we do that through a kalawasa or a core sample of the material, because different wastes can have layers that are built into it. So we always want to encapsulate the full spectrum of the material. So a plant technician would don a harness and attach himself to, it's called a horizontal lifeline, but basically it's a system that prevents him from falling and hitting the ground if there's any sort of issue. So he'd attach himself to all that safety material, climb on top of the tanker, and grab this core sample of the waste. That sample is then brought into our lab. We're going to run a gambit of analysis. Once again, we're going to test for flash. We're going to test for pH. We're going to perform an analysis for heavy metals to ensure that sample of that specific waste stream is matching the original profile that came in with the sample. So it's a due diligence thing that we're ensuring that there's no variances, because there's a lot of dynamics that are associated with wastewater, especially if there is multi-layers or potential solids or sludge in the material. So what we're doing is we're comparing that sample from the full load of the material to the profile that initially was completed, which is I guess I like to refer to it as the birth certificate of the waste. It kind of describes everything about the waste.
And so once that's done, we unload the truck, I presume, and then the real kind of cool stuff starts, right? So we unload the truck, and we have multiple treatment options or technologies that we use depending on which plant. They're all set up a little bit differently from one another, but the core process is the same. And that's, we have to get out whatever is in the wastewater pollutant from a pollutant standpoint so that we can recycle it compliantly back to the city sewer. So what is that cool process? What happens once we unload the truck?
Yeah, so the process is it's quite a large process, but there's a lot of stages, and some are very simple, but the simplicity of it can also help prevent further pollution. So identification of what categorical waste stream it is. And what I mean by that is there's three main categories of waste streams. There's heavy metal waste streams, or metals categorical. There's organic categorical, and then there's also oils categorical. And part of this process, just from offloading, is separation of oil categorical and organic categorical waste streams. Because if you introduce an organic categorical waste stream through a system that contains oils, well, you're adding petroleum, which is something we're trying to remove from the water and do remove from the water. But why add something to a material that might not have it? So the first step would be segregation of the waste stream based on its category. The second part to that is bench samples and bench testing. So we would take samples of that waste stream and replicate treatment on a small scale to determine the best treatment method and chemical consumption, and really break down what is the best method for removing these pollutants based on our lab analysis. So after the offload and decision of segregation of material, where does this waste go? It's essentially creating a little treatment scale in our lab, and it's done to scale. So if we have X amount of volume of waste and we add X amount of chemical, we know how to scale that onto a size where it's replicating a 5,000 gallon tank of material. And it's going to start with generally agitation, depending on the treatment method. We have 3 primary treatment methods, but most of them involve agitation of the waste or mixing. And then once again, if it's an oily waste stream, we have to remove that oil initially prior to further treatment. So in that case, we would break those oils out of solution, causing them to float to the top of the wastewater tank by adding chemicals such as sulfuric acid and some other starch-based chemistry, performing that action while mixing, killing the mixers after the chemical has been added, and then actually gauging the sample pulled from the tank to see how well that treat actually performed.
Okay, so in your book, I think you refer to that as the recipe, or I've heard you refer to it as the recipe. And when I hear you say it, it kind of reminds me of like a chef, for example, is putting all kinds of ingredients together to make a particular recipe. And that's what we get is the byproduct of that recipe. And so our job is to really engineer the recipe. We actually use our own recipe to take apart the recipe that was that was employed in the first place to make the waste. Am I on the right track there?
Oh yeah, you hit it right on the head, and that's exactly what it is. It is a recipe, and part of the real part that's real invigorating to me about it is that recipe kind of changes all the time. So like every day, there's a new challenge that's associated with material, and for the most part, there is similarities. But if you can just, maybe add a little bit more chemical or adjust it so you're creating a little bit less treatment flock or the sludge, the byproduct of treatment, we're always looking for better ways to minimize our waste. But yeah, that's pretty much it, a recipe to kind of disassemble the recipe that created the waste initially.
Okay. And you mentioned the solids, and the solids are everything that we remove essentially comes out as a solid. So the water, the solids are bound to the water when it comes into us by this recipe or whatever, and then our recipe re-engineer or disengineers maybe is a better word. I don't know. And whatever's in there from a pollutant standpoint generally comes out as a sludge, what we would call a sludge or a flock. And as I understand it, you can do that. You can do the recipe a bunch of different ways, but ultimately you want to achieve the result with the least amount of solids. So you want to get everything out with the least amount of solids because that makes it easier for us to recycle more of the water. Is that right?
Yeah, that's correct. We're always looking at ways to minimize our waste byproduct. And the sludge content or the flock content is something that is part of that process. So we want to recycle as much of that water as possible, and that's done by consistently analyzing and changing certain recipes. If we have a large amount of sludge that's generated, we're going to try a lot of different alternatives for the recipes to see what we can do to minimize that.
Okay, so once we've done we've employed our recipe, we've removed the pollutants. What do we do with the waste then? So it's been brought in, we treat it. It's remove the pollutants. Now what? I mean, this is the cool part. This is the sustainability part, as I understand it.
Yeah. So after the treatment's been performed, I'll revert back to analysis. There's always a lot of analysis involved in the wastewater world. So after we created that recipe and implemented it on a large scale, and that treat has been performed, we're going to take a sample of that treated wastewater, and we're going to analyze it again to ensure that we're meeting compliance from the sewage district. So we always want to be looking at, hey, did we do an effective job of removing this contaminant? If we didn't, well, then we have to re-engineer that wastewater treat and revisit it. But what we're always looking for is maximum removal of heavy metals. And that starts with the analysis again. So after the treat is performed, we're going to analyze that wastewater again to ensure it meets compliance with the sewage district.
Okay. And I forgot to ask you about that before, but you mentioned it there. So our wastewater facilities have their own permits that require us to meet standards established by the sewer district for us to discharge the water back into it.
Yep, that is correct. Yep. So the standards are set for us. Those standards, that's the law of the land. So that's what we have to do. That is the goal. And then just as an extra set of security measure, we have certain parameters where, if our discharge limitation, for example, is 100 parts per million on fats, oils, and grease, well, we're going to put a buffer zone in there always to ensure that there's no compliance issues down the line. Mm. So, for example, we would never discharge anything below 80 ppm petroleum-based contaminant in a wastewater.
Yeah, so we build in a cushion. Yeah. Mm-hmm. Okay, and when we discharge the water, so we did 4 steps of analysis. If and it's maybe more if something doesn't go right with our recipe. We verify that we meet the permit. Then the wastewater we discharge. We essentially gravity unload it again into the sewer system, but it passes through a couple of things on its way there.
Yeah, correct. So it passes through initially as we're discharging. We have kind of an extra security feature too called an oil coalescing pit. So the wastewater is then, after it's been cleared from the lab, obviously, goes through a series of plumbing and empties into this pit that has these 2 coalescing packs that are going to separate any potential droplets of petroleum that could still reside or potentially could have been stuck to the side of a tank or something. So that's just an extra security feature.
Okay.
For us to ensure compliance. Also, there's inline pH meters that we have just to ensure that the pHs are always at the proper parameters. And past that, there's 2 specific pieces of equipment that are used all the time. There's one called an auto sampler, and then there's also another piece of equipment called a flow meter. So the auto sampler is a way for us to gather 24-hour gather composite samples of material that's been discharged through a certain time frame. And that's also tied together with our flow meters as well, which is keeping track of how much flow or how many gallons have been discharged through a specific wastewater flume or outfall, because every wastewater type of categorical wastewater has a different specific outfall that has to be monitored separately.
Okay. And so at that point, getting back to kind of where we started at the beginning with people's awareness of where wastewater goes, at that point, the treated wastewater goes through the coalescing, goes through the sampler, the flow meters, and then it basically drops into the sewer system just like anything else that you would have from your house go into the sewer system or your workplace or wherever, right?
Yeah, that's correct. Yep, all the materials discharged into the sanitary sewer system, and then through a network of pipes and lift stations. Eventually, it ends up at the municipal treatment plant, and we'll go through then a biological treatment process at that point.
Huh. So that's cool. So even if you don't really have an understanding of what we do, which most people don't, the end is really the same. It's just turn on the faucet, water comes out, you use it, it goes down into the sink, down to the municipal water treatment facility, and then back into the environment, into a lake or a stream or whatever, and so that it can be used again for all kinds of purposes, recreational, water, which we all need, and processes too, to make things.
Yeah, it really is a life cycle of water and of wastewater because it is continuous. It's being pulled from an area and then used in a process. Those contaminants are then added through that process. Then we receive it, remove those contaminants, and then back down to the sewer system it goes. A little bit of additional treatment through biological, and then back into a body of water. And it truly is like an encompassing circular cycle. Yeah. And it really is a beautiful thing. It's cool. It's an awesome industry to be in, and to see that happen on a daily basis, it energizes me every day.
Well, Zach, thank you so much for being on the show. How can people reach out to you if they want to connect with you, Zach? What should they do?
Yeah, so if they want to connect with me, you can reach out on me on my LinkedIn, or also through ERC Midwest website. We have multiple different avenues that you can reach myself or any one of our experts in the industry. So that's, or my phone number, which I think would probably be on there as well too. But our website or my LinkedIn account would be great avenues for reaching out, and I'm here to answer any questions.
All right. And as I said at the beginning, if you want a copy of Zach's ebook, The Life Cycle of Wastewater, you can find that on our website at www.ercmidwest.com. Zach, thanks for writing the book. Thanks for coming on our show and sharing your enthusiasm and your expertise on a subject that's really, really cool and instrumental in the way that our world works, but that so many people just don't know about. Now they do.
Thanks for having me, and I look forward to hearing back from someone.
Thank you for listening to the Working Without Waste podcast. If you like what we're doing, please subscribe to the podcast on our website at www.ercmidwest.com or wherever you listen to podcasts. We'd also be grateful if you'd rate the podcast and leave a review. That helps other people find us and gets the show's value into more people's ears.